Look at this question now. We want to solve this question. What must be subtracted from this number so that it will be divisible by this? There's something we call remainders theorem. Remainders theorem. Remainders theorem. This remainders theorem is saying that we use this one to divide this. What will be the remainder? If the remainder of this one, when we use this to divide this, if the remainder is 0, that means this is a factor of this. But as it is now, this is not a factor of this. Because you are trying to tell us that what number should we subtract from this one that will make this one to be a factor of this. When we want to do this one, we always do something like, if you already know that this is a factor, I want to know the remainder of this. I'll just say, okay, y minus 2 equals to 0. Then y equals to what? 0 plus 2. And that's 2. So I will now put values of y inside this place. Anywhere I see y, I'll put 2. 6, open bracket, 2 raised to power 3, plus 4, open bracket, 2 raised to power 2, minus 2, plus what? 5. If I do that, it's not going to give me a what? It's not going to give me 0. Therefore, it is not a factor of it. So what do I need to subtract from it so that it can be a factor? The meaning is that number that we get, that remainder we get, is what we need to subtract from it for it to be a factor. Now what you now do is that you now come back here. Okay, let's try that number. We have y minus 2 equals what? Equals to 0, yes. 6, open bracket, no. Therefore, y equals to what? 2, abi? Yes. So 6, 2 raised to power 3, plus 4, 2 raised to power 2. Like if I want to do this, I will not be writing all this one. I will just come to, I already know this one is what? 8, 6 times 8, 40, minus what? 2, plus what? 5. Let me add this one together. 6 times 8, 48, abi? 4 times 4, 16. Minus what? 2, plus what? 5. If I add this one, this is 67. It's 67. Right? And if it's going to be a factor of this one, it's supposed to be 0. You get what I'm saying? If this is going to be a factor of, if this one is going to be a factor of this one, when we put this 2, it's supposed to give us 0. So if it's not giving us 0, that means 67 is given to us. I mean, what can we subtract from 67 that will give us 0? It's still 67. So therefore, the number is what? 67. It's still 67 if you subtract from 67 and give what? 0. They can give you that question. What number will be subtracted from this so that this will become a what? A factor of it. Then I have to find this and put it. The number that I get is what I must subtract for it to become a what? A factor.
But I have a question. Please, how do you get out
2? Y minus 2 is equals to 0. That means y is what? It's 2. I draw this 2 out.
What if I'm giving 3? So I'll just use that.
Yes. If it is minus 3 that is there, that will be y equals to 3. If it is plus 3 that is there, that will be y equals to what? Minus 3. So that's what we say. So we now try it. Put it inside. Then it gives this. Since they are asking what number must be subtracted, 67 is the number that must be subtracted to give us a 0 remainder. Okay. Looking at this question, the question is trying to tell us that this one is equal to what? Y. Why this one is also equal to what? Y. That means the two of them are both equal. That's what it's trying to say. So they are equal to each other. So you can find x first. When you get x, you use it to find what? Y. You understand that? So from here, these two, they are equal. You can bring them together. That means log x is equal to what? Log 9, 2x what? Minus 1. They are equal. So from here now, I will turn this one. This is already base what? 3. I also make this one base what? 3. Now when you are making, I say log this 3x equals to what? Log 3 raised to what? 2. 2x minus 1. Now I need to remove this 2 from here and bring it here. When I'm doing that, I'll be log 3x Okay, let me even do it like this. Okay, I can do it like that. 3x equals what? This one will come here and become the reciprocal. When these two come here, it becomes 1 over 2. This 2, when it leaves this place, becomes 1 over 2 log 3, 2x minus what? 1. Are you getting that? Now, this one cancel what? This one. But before we cancel it, let's be careful of cancelling. Be careful of cancelling. When we cancel, let's carry this half to this side. This half, whenever any number is here on the log, it becomes a power here. Abi? That will be log this 3x equals what? Log this 3, 2x minus 1 raised by what? Half. Right? So now you can now cancel. So that means x equals what?
2x minus 1.
2x minus 1 raised by what? Half. Right? Now let me rewrite out. It will not become something like this. X equals to square root of. Okay, I want to remove that this half here. X equals to. If I want to remove it, I will put this 2 on 2. 2 on this side. 2 on that side. So raised by 2 here. This one also 2x minus 1. 1 over 2 times 2 also. 2 will cancel 2. Because I want to remove this 2 here. That was how I put that 2. I raise this power of 2. Power of what? 2. So what you do to one side, you do to the other side. So that was what was on there. So this one has become x squared equals what? 2x minus 1. No more this one now. That half had gone. So we now take out of the x squared minus what? 2x plus 1 equals what? 0. Do you get that? Factorization. So we factorize this, that would have what? X squared minus x plus 1 equals to 0. X minus 1 minus 1 x minus 1 equals what? 0. X minus 1 x minus 1 equals to 0.
Yes.
X equals to what? 1. How many times? Twice. So I've gotten x now. So I'll go back to the question to go and get y. You know, they told us that log base 3x equals to what? Y. And we know that x is what? 1. So let me put x1 here. That means log base 3 1 equals to what? Y. Right? So that means if I want to do this now, I'll say if I want to cross this, I want to remove this log from here. I'll just say 3 raised by y equals to what? 1. Hope you know. 3 raised by y equals to what? 1. In fact, looking at this, I can solve it directly because logarithm of any log 1 to any base is what? Is 0. Log 1. Whatever base must be, even if you put yourself as a base of log 1, it's still 0. So, but from here, to just make it so that I can prove that. So from here, now see 3 raised by y, this one is 3 raised by 0. 3 raised by 0 is 1. 3 cancel 3. So therefore, y equals to what? 0. Hey, y equals to what? 0. And since x is 1 twice, if I try the other, it's still 1 now. I cannot be trying 1. I've tried 1 here. I still want to try 1 again. Since 1 has given me 0, if I try the other one, it's also going to give me what? 0. If you try it here, it will give you what? 0. Imagine we try it here. We put 1 here. Abi? 2 times 1, 2. 2 minus 1, 1. Log 9, log 1 base what? 9. It's still what? 0. So therefore, y equals to what? 0. So therefore, x equals to 1, y equals to what? 0. Now looking at this question, they all have the same base. So we deal with base and power in logarithm, just as we do in indices. The two of them are interwoven. So from this place now, since they have the same power, first thing first, according to the laws of logarithm, one of the laws of logarithm tells us that if we have something like n log m log a m. If you have something like this, one of the laws of logarithm told us that we can turn it like this to become, it can be equals to log a m raised by what? N. You agree? So that's the law we are going to first use in this case. So I'm going to bring it down to what? Log 2 a raised by what? 3. Plus what? Log 2 a raised by what? 5. Minus what? Log 2 a raised by what? 6. Equals to what? Log 2 64. Are you following? Now, all the logarithm here have the same base, so I can pick one base. So it becomes log base 2 a raised by 3 times, because of addition, times what? A raised by 5 over what? A raised by 6.
It turns to multiplication.
Addition turns to multiplication, subtraction turns to what? Division. Because they all have the same what? Base. Equals to what? Log 264. Eh? Look at what we have here now. This has cancelled this.
Because they are the same.
They have the same base. So from here, this a raised by what? 8. We are multiplying, we had 3 plus what? 5. Over what? A raised by what? 6. Equals to what? 64. This one, we what? Subtract. And that what? A raised by 2 equals to what? 64. Another way to do this, how do we do this?
We bring out 64.
No, just find the square root. Take square root of both sides.
Oh.
That one what? Square root of a, square root of 64. This one cancel this. What's square root of 64? 8. Abi?
Yes.
Therefore,
The answer is
a equals to what? 8. You see that?